We started by saying we need to calculate two things: average energy per oscillator and total number of oscillators. We derived the expression for average energy per oscillator to be this thing. Now, to find the total number of oscillators, luckily we don't have as complicated a derivation as the previous time. So the number density of states, that is, some things are just given to us directly, so it sort of simplifies our calculation. So the thing is, number density of states, meaning the number of allowed energy states in any interval nu and nu plus d nu, meaning let's say between 105 Hz and 110 Hz, there are 8 pi nu cube d nu by c cubed allowed states. So what do I mean by allowed states? Like I said, an atom cannot have any and every energy value, right? There are specific values of energy which it is allowed to have. So between 105 Hz and 110 Hz, for example, there are a specific number of values which the atom can, values of energy which the atom is allowed to possess. So this number of values is what I refer to as number density of states, and that is given to be 8 pi nu square d nu upon c cube. So how this came about? This was derived by Rayleigh-Jean, but the derivation is not part of our course, so we will not go into it. We will just accept this as a given. So now that we have the number of allowed states and the energy of an oscillator in one state, we multiply both, we will find out the energy density in that frequency range, meaning, I'm sorry, one second. Yeah, so sorry about the interruption. We have the number of allowed states and the average energy of per energy state. Let's say the average energy per energy state. So you multiply both, you will get the total energy between nu and nu plus d nu at temperature T Kelvin. So multiplying what and what? Multiplying this expression which was just given to us and this which we derived from the previous segment. You multiply both, you will get this expression, and this is the expression for energy in terms of frequency and temperature. So when we started quantum, we basically said the energy emitted by an object is a function of its frequency and temperature. At that point we didn't have a proper expression, and all this process which we went through was to find out an expression for energy in terms of nu and t, and this is that expression which we wanted, which was derived by Planck.